Thank you so much, Shahzad sir, for joining us today. Today we have a session on Smart Agri Tech Lab, and Shahzad sir has been kind enough to share his work और इन्होंने पीछे काफ़ी अरसे से जो जो काम किया है लैब के अंदर वो हमारे साथ आज शेयर करेंगे। तो क्वेश्चंस जो हैं वो ओपन हैं Q&A के अंदर जाके अगर कोई भी पार्टिसिपेंट लिखना चाहे तो उसमें जाके लिख दें, मैं फिर शहजाद साहब को प्रॉम्प्ट करके सवाल पूछ लूँगा, and then that's how we can start this. So over to you, Shahzad sir. आपका वो म्यूट आ रहा है। हाँ, you good.
Thank you very much, Saad Sahab. Assalamu alaikum, everyone. So I'm really, grateful for especially Saad Sahab and his team for first, enrolling me in the Agri-Tech WhatsApp group, and then subsequently, inviting me for this talk on the later work I'm doing at NUST. So by the title of the presentation, you can see this would be on Smart Agri-Tech Lab. I'm a director of that lab in the NUST. So I'm associate professor in the School of Electrical Engineering and Computer Science at National University of Sciences and Technology in Islamabad. So presently I'm heading a department with the name Digital Systems and Signal Processing. So let me just a little bit set the background. I mean, from where I am coming. So maybe most of you know about the NUST. Alhamdulillah, this is ranked one university in Pakistan as per HEC annual ranking system. As per the QS ranking system, we are, Alhamdulillah, placed 76th in the Asia. And in 2021, we were 358th in the world. So it's a beautiful campus in Islamabad. Maybe if you have seen that, it's over 700 acre kind of spread over that kind of land. So it's a very, very serene place in Islamabad. So I would invite everyone to visit this place if you haven't already visited this. So I'm part of School of Electrical Engineering and Computer Science in NUST. So we have different schools in NUST. Like we have the School of Electrical Engineering. So similarly, we have the School of Mechanical Engineering, Chemical Engineering, and so on. So in electrical engineering, we are again ranked very well in the world. We are at 256th position in world in electrical engineering, and in computer science, we are at 239 position. So right now I am sitting in the building. So we call this as a niche. So this is NUST Interdisciplinary Cluster for Higher Education. So this is kind of first of its kind of center in Pakistan. So where we have kind of different kind of labs belonging to different departments. So idea is to promote the interdisciplinary research at a single place. So if I need to collaborate with someone with maybe IC design or maybe in energy systems, so the lab is situated well within this building. So our idea is to kind of do the disruptive research on the disruptive technologies to add some kind of niche to the existing technologies to do our penetration in the market. This is small corner I have in that building at level 3. So my focus area for this lab is mainly on the agri hardware and metrology. So I'll present some of the work we are doing in this lab. So then the idea is to integrate the IoT, Internet of Things technologies with the gadgets to make them a little bit smart. So let the gadgets speak themselves. So whatever we are doing in the lab, kind of we are making sure we integrate IoT technologies with those sensors. We have a small scale prototyping facility in this lab. We have a small PCB manufacturing setup and 3D printed ideas to, whatever I'll show you today is kind of, we did the prototyping mostly in the lab. So the idea is, just to think about something and then maybe right away try to, test it, develop it, and then test it within the lab and the outside. The very last thing I'm trying to focus is where my other, lab, which was situated in the School of Electrical Engineering seats. Um, we call that SEEKS. That is about, I was doing mostly work on the adaptive signal processing. This is where, my PhD work was, my focus was in that domain. So I am trying to bring in, the AI, the signal processing with the agriculture technologies. So I'll present few of the things we are trying to work in that domain as well. So first, I'll talk a little bit about the agriculture hardware and the metrology. So maybe I'll just, I have one slide on each kind of prototype or a product or a project, you may call it. So the first one among it is the AgriFarm multimeter. So this is the work we started perhaps a year or so ago. So our idea was to, come up with a portable handheld multimeter, soil moisture meter to start with. We started with, our sole focus was to capture the soil moisture. And some of the, technologies already that were already present in the market were, maybe those were something like, they were not, ruggedized enough to go to the field, right? They were more like a hobby kind of sensors present in the market, or the one which were kind of very, professional, were very expensive. And then, I mean, like government of Pakistan, or the government, mainly the government of Punjab, used to, give those kind of meters to the farmers on the subsidized rate. But that meter costed, uh, kind of 40-50,000 rupees, Pakistan rupees, to them. So our first, goal was to kind of come up with something which is low cost and indigenous. So we just focus on that sole purpose, to develop a kind of a very professional kind of very accurate soil moisture meter, which should actually go in the hand of farmer, right? So then the second point, second thing we did with that meter was to bring in some extra features. So for example, we coupled the IoT technology with that. So it's not only, so we kept the screen, the display screen on the portable meter as well, but we also put in the IoT sensor with that meter, so that if, let's suppose, you need to do some post processing, some analytics on that, pattern, so your data must be recorded somewhere on the server. So our kind of, we used the typical dry oven method, which is very common for measuring the soil moisture, but it is a lab oriented method. You need to bring your samples in the lab, and then you do some experimentation. There is some procedural, a way to measure the soil moisture. It takes, some hours before you conclude the real moisture. Our idea was to, do it instantaneously, to develop a sensor which should measure the soil moisture at the spot. So we not only did the soil moisture, we also measured the soil temperature as well. So you may see the probe. So this is the real kind of meter we have. So maybe I can show you in the screen as well. So we have, this is the probe. It's kind of 8-inch probe. So we took an international product, and we saw, I mean, what should be the, typical specifications for this. So although this could be tailored to any length, so maybe, for example, I show you another probe, which is kind of 40-inch probe. So is could be, integrated with the same meter. You just need to open this probe from this, gadget, and you need to insert another probe of any, other length. So the tip you can see in this, here. So this is actually, this sensor measures the localized moisture at that depth and also the temperature as well, the soil temperature. So the more the depth of the roots is, maybe you need to use a larger size probe to measure the
Shahzad sir,
moisture point at that.
we have a
Sorry.
question. The question is that is this being used commercially anywhere in Pakistan?
Well, we have actually given a couple of meters to the Agri Department Punjab for final validation, and they are doing the field testing as per we speak. Right, we are getting the data on the portal, so they have deployed on their site. So we wanted to validate it with the end user first, and then we want to go to we would like to go to the market there. So after a thorough validation, although we did validation in the lab, some controlled validation in the field as well. We compared the method. This is Persian with other kind of commercial meters and even the dry oven method. So, but we haven't went commercially full scale yet. So we're talking to few people here and there, but still we would like to see the final validation from the agriculture department Punjab. Did I answer your question?
Yeah, that's fine. We can move
Okay.
on.
Right. So not only soil parameters, we also thought to put in some sensors on the top of like on this side. Maybe I can show you another meter. So this is another variant. So this is a little bit older version. So we kind of put on few sensors inside this enclosure. For example, to measure the temperature, humidity, light intensity. For example, the meter the sensor you can see here would be used for the measurement of light intensity, and these kind of parameters we can easily integrate as per the user requirement. So the major IoT technologies at the moment we are doing in the lab and could be integrated to any kind of sensor. We have the capability, and the hardware for them is the GSM, GPRS, Wi-Fi, LoRa, and the mesh. We also did some testing at the LAN as well. So if there is a provision of LAN, at that facility, so that could also be integrated. So as I indicated, our major collaborators as per now is Irrigation Department Punjab. So we have MOU and LOI with them on this technology, and there is another technological partner that is a Cyflare, Pakistan. So they are like doing something in the IoT domain. So we are kind of collaborating with them as well. So we're using their modules and things like that. The next in line is, okay, so I can't see my title here. So, okay, anyways, it has to be smart silos perhaps. Okay, smart silos. So I did a project with Pakistan Agriculture Research Council on this topic. So the very idea was to develop a silo where you should able to thoroughly monitor the inside silo environment. So the basic thing we started with was the temperature. So it's like you need to measure the 3D kind of heat map inside the silo. So we place the sensors in a kind of 3D grid form. So we took different probes and placed that per our own choice and the requirement. And you can for example, if you see this figure, so you can place as many as probe as you would like, and of course you need to make the provision of displacement while the construction of this this silo. But of course you can skip as many as you want, but the density is again controlled by the user. You can put multiple sensors in a single chain, right? So idea is if there is some spot which is which is behaving abnormally, maybe there is some fungus which is developing at that spot, so you should able to capture high resolution data from the inside. So we developed the complete control, and then the next part was now to do some sort of aeration to maybe to push some hot air, or maybe the ambient air, for example, to do the aeration inside the whatever grain you have, or inside the silo. So we develop the control and the sensing part. Again, this is again uh, uh, coupled with the IoT technologies. So we integrated that technology with the PV just to make this autonomous. Uh, and then we also integrated acoustic sensor in case there is certain pest attack inside, and you get some sort of acoustic signature. You should be able to capture that as well. And beside that, we also were measuring CO2 and these kind of emissions from the inside. So this silo could be used anywhere, in the rice industry. We actually tested with this one of the major industry in Pakistan. We tested this with the Angro. I mean, there are a lot of applications where you can use this kind of silo. So idea is to monitor the inside silo environment and then do some sort of controlled aeration with, I mean, control. I mean, by controlling, I mean the temperature and the humidity control of the air. So next was I mean, we did a small variation to this smart silo. We came up with an idea of sense ball. So the idea was, I mean, like if you look at the Pakistan, horizon, so mostly the storages are, they are like open sky storages. They are not like closed silos, as I mentioned in this slide. So mostly, people stack them the sacks outside, and then there are all sort of pest attacks, and maybe even you have the rats going into that kind of grain. If you talk about the wheat, or maybe any kind of storage. So our idea was to develop this small ball. So I have that kind of. This is a little bit bigger variant, but so idea is to put this kind of ball to randomly, if you have, let's say, 1,000 sacks stored outside in an open environment. So maybe you take maybe 100 balls and place randomly inside different sacks. So now they'll form a mesh network. So battery life, we put a battery and it supports almost one year if you take one reading per day perhaps. Now by using this sensor, again, now you can monitor what's the moisture or the temperature inside that godam, or inside that that big, we call generally the people call this ganji storage, right? So उसके अंदर आप जो है वो different जगह पे place कर दें, और इसमें भी acoustic sensor है. अगर कोई जैसे rat attack हो रहा है या कोई otherwise different तरह की कोई problems उसमें आ रही हैं, for example उसके अंदर या बारिश की वजह से कहीं ह्यूमिडिटी या टेम्परेचर या उस वेटनेस उसके अंदर आ गई है. तो दिस इज वन ऑफ द एप्लीकेशन वी स्टार्टेड विद दिस कॉन्सेप्ट ऑफ बॉल. तो आइडिया इज कि आप शुरू में इसको जब पैक कर रहे हैं इसके अंदर डाल दीजिए रैंडमली, और सीजन के एंड पे जब आप निकाल रहे हैं तो इसको निकाल लें और बैटरी चेंज करें, और अगली दफा फिर इसी को रीयूज कर रहे हो. So, but later on we thought of extending this ball for other application. For example, अगर हम सप्लाई चेन की बात करते हैं तो हमने इसके अंदर जीपीएस ट्रैकर डाल दिया. इसके अंदर you can see all sort of sensors, temperature, humidity, again maybe light intensity. So we can put as many as we want and maybe as per the user requirement. So gas emission इसमें अगर आपकी है total TVOC भी हम कर सकते हैं. Then acoustic is a major thing कि आप किसी भी तरह के acoustic signature जैसे capture कर सकते हैं. So this could also be used in storage and other supply chain industry as well. Then because we were dealing with a lot of temperature, humidity, and these kind of light intensity sensors, so we thought of extending this to the a small mini weather station. So we developed a kind of low cost weather station. by employing rain level sensing, wind speed, wind direction, atmospheric pressure, and then air quality monitoring. You can do up to a certain extent, light intensity, and then air temperature and the humidity. So we actually developed this whole weather station, and again so at present we are we have deployed it somewhere and getting the data in the real time. So again, the resolution of the data would be at the end of the end user. किस rate के ऊपर उसको data को जा रहा है. So again, I think this is very important device for a farmer if he needs to decide कि उसमें spray कब करना है या again Persian agriculture के अंदर जितने भी ये parameters are, they are going to contribute immensely. So there is another project we are working at present. So that is about this, cattle vital. So one thing you can see in the neck of this buffalo is, so this is specially oriented to the buffalo, but could be applicable to any cattle like cow or even sheep as well. So this is a small kind of collar type, you may say. We put the sensor inside. So using this, you can see the similar is weird in this neck of buffalo. So iska jo sensor है, that part is here. So you can measure all the activity related. I mean, whether this is is walking, sitting, or standing, or whatever, using these sensors which are residing in this collar. So beside this, our application was to detect the heat of the buffalo, because buffalo, the problem with buffalo is that it's generally considered to be a a shy animal. So it does not show much sign when this is in heat. So farmer needs to decide when to do the artificial insemination. Nowadays, people generally use to do the insemination artificially, right? So we also developed a probe to not only, I mean, the collar was the main responsibility of collar was to capture the activity of the cow or the buffalo. Beside that, we also developed a probe. So on top of that, I mean, this is the probe we developed. So we put in the conductivity sensor. So this is to measure the vaginal conductivity. And then we also put the temperature sensor inside the probe and a pH sensor as well. So using these parameters, because literature shown that whenever the cattle is in heat, so it shows a visible change in these parameters. So a farmer needs to tentatively choose a window when his or her animal is in heat. So within that window, one needs to measure these parameters by inserting this into the vagina of the animal. And then this collar is going to give the constant activity of that animal. So by applying the machine learning algorithm, we can exactly detect when the heat of the animal peaks, so that this could be inseminated with the semen of a bull. So this is this is an ongoing project. We also put a GPS tracker with this. So there is another small device you can see. So this is a cattle tracker. So there is a GPS sensor, and we are using LoRa to transmit those parameters. So if you haven't heard, so maybe by putting this tracker into the neck or whatever, you could able to exactly track where your animal is or where your herd is at the moment. So this is again we tested it with the LoRa technology, but could be converted to any kind of IoT technology. A project we are working again with Irrigation Department Punjab is on the flow measurement of the channels. So let me see. Okay. Sorry, my title slide is just hidden. Not sure how
It's a
to.
water flow sensor.
Oh, okay. It's a water flow sensor. Yeah. Right. So again, the idea is, just to measure the volume of the water which is going into the field, right? So by again integrating the soil moisture sensors and this water flow sensor, you should exactly able to capture that how much water is going into the field, and then maybe you can, you can budget your water in a much wiser manner if what is the input to the field. And but I mean you can use this kind of this data for example the yield estimation. At the end of the day, maybe you are interested, okay, this is the yield you are getting, this was the water you pumped in, and then you can optimize your crop, maybe sowing patterns and so on. So this is something could be used for both the open channels and the closed channels as well. So we have the canal water channels and the tube wells. We are developing this technology for both of them to measure not only the level of the water in the field, but also the velocity and the flow of the water. And by doing this, we would be measuring the volume of the water going into the field. A technology which is actually being developed by one of my colleagues, I just thought to present it here as well, is on this. Again, sorry, so let me just shift back to just see the title. Okay, so this is like mango maturity meter. So actually the idea is to, without uh, you know doing this invasive kind of testing, one should able to measure the maturity of the mango by just placing a sensor outside of that fruit. So they tested it on apple, and they also tested on different variants of the mangoes as well with different universities. So I think they have very mature kind of this meter. Maybe this could be commercialized with the help of industry. Another project again was, I think, on spring drones. So this is also already being used by some of the farmers. I just wanted to introduce this. So again, this is not developed by my lab, but there is another lab in NUST. So with these specs, like I think that with the 20-minute charge, they can cover 2 acres and then 6 acres per hour, and then 40 acres per day. And there is a 10-liter tank which is deployed on this drone. These are some numbers which could be you can say like 80% water and so on. This is already being used by some of the farmers. So the purpose here is just to introduce with the audience. Some of the AI-based techniques which I'm working on is, for example, this is work with my MS student. So we are trying to estimate the yield of on-tree yield of, for example, in this case, oranges. But again, the idea is to replicate this for the other, fruits as well. For example, mangoes or davas and so on. So idea is maybe by just taking the smartphone, maybe you can take a selfie stick or something like that. You just make a round around this tree and capture the video at certain stage when your food is being ripened or already ripened. So as the idea is just to estimate the overall yield of the orchard, right? So again, the next level would be maybe to just classify what kind of oranges are there, and maybe what is how much percentage is class A fruit, how much percentage is maybe class B fruit in an orchard or on a tree, right? So we have collected some of the data sets from some of the orchards nearby to Islamabad in Fatehjang. So we have labeled those images, and we have applied some sort of AI algorithms on that to do the yield estimation. So it's just a bit ongoing, but at the end of the day, we are just expecting to develop an app, a mobile phone app, which a farmer should have to measure the yield of its orchard, right? Uh, so, uh, so this is a concept on which I am working at present. Again, because smartphone is such a powerful gadget nowadays, and almost every other person have it. In fact, they have better smartphones than we do. The idea is to utilize the power of the smartphone to come up with different applications which can help the farming community. So, for example, in this part, we are trying to estimate the disease of the wheat. So, at present, we are targeting 6 disease types in the wheat. So again, we have some data set which is scrapped from the internet. We trained AI model on that. So we are getting a decent accuracy of 98%. Of course, this is more controlled data set, but we have planned to go to the field, and this is where we would like to collaborate with others as well. So if they can help us getting the data set of different crops and different orchards, and we have quite good resources with us in terms of students, in terms of RAs. We can pivot our thesis, MS thesis, PhD thesis on this. So the idea is using the smartphone, one should be able to detect the disease, whether that's in wheat. There is another work that is on the rice as well. So we at present are just targeting 3 disease in the rice, and using AI we should be able to detect which kind of disease is even you can when the disease is in very initial stages, you should be able to kind of detect it and then do some preventive measures as well. So again, this should come in the form of an app with the farmer. So using that, he or she should be able to detect the disease. A small work we did was, there is a huge data set which is present on the Agri portal of, I think, Punjab government only, that is a miss. So we just, scrapped some data set. So we just recently send a publication on that. So for the wheat, so we are trying to analyze the district-wise prices of the wheat in Pakistan. So maybe just to see what's the parity between prices, but this could be replicated to any kind of commodity price, because we have lot of data over there. So one should be able to measure the trends, seasonal trends, and other kind of trends from their data set using the AI. So I think with this, I thank you all for listening. And so if you have any questions.
Yeah. Thank you, Shahzad, for that very good introduction. I think there are a couple of questions and there's a couple of observations that Faisal Shahjahan Saab also has. Faisal Saab is a very senior person in the industry. काफ़ी उनके insights भी हैं, काफ़ी अरसे से इस area में काम कर रहे हैं. लेकिन मैं before I hand it over to him, I will just ask you a couple of questions the folks have asked, and then we can take it from there. तो पहला एक सवाल था कि are you using third party analytics, or the analytical software development is also being done by your lab?
हम जो है वो खुद डेवलप कर रहे हैं. We're developing the algorithms. So I'm working in deep learning side, not only for agriculture, but for some other domains as well, for energy analytics and so on. So we're doing it from scratch ourselves.
ठीक हो गया। और एक और सवाल उनका था कि मेरा ख्याल है एकॉस्टिक सिग्नेचर के हवाले से, व्हाट्स द थॉट बिहाइंड द एकॉस्टिक सिग्नेचर, आपने एक पार्ट में
ओके,
मेंशन की।
सो फ्रेंकली हमने सोचा कि लेट्स सपोज जो मैंने ओपन स्पेस स्टोरेज की बात की, मे बी सम ऑफ अस आर अवेयर कि अगर आप जीटी रोड पे ट्रैवल करें, स्पेशली गुजरावाला और आगे पीछे ना, दे हैव काइंड ऑफ स्पेशली पैडी के सीजन में तो बिल्कुल ओपन स्पेस में उन्होंने स्टैक की होती है पूरी, जो है ना, अपने सैक्स को किया स्टैक किया होता है। मतलब मूंजी, उसको गंजी मेथड कहते हैं, गंजी मतलब लगाई होती है, मतलब उसके ऊपर कोई तरपाल डाल देते हैं। या अब उसमें जो प्रॉब्लम्स आते हैं ना, वो रेड इज अ मेजर कंसर्न फॉर वी टॉक विद द पीपल कि जी किस तरह के प्रॉब्लम्स आते हैं इस तरह के स्टोरेज के अंदर। तो उन्होंने कहा जी एक तो उसको चूहा लग जाता है। तो हमने कहा अच्छा, और बाकी प्रॉब्लम्स हैं कि अंदर जो है ना बारिश की वजह से कहीं जो है ना उसका जो है वो मॉइस्चर ज्यादा हो गया एंड सो ऑन। तो वो बेसिकली हमने सोचा अच्छा, और बर्ड्स अटैक, बर्ड्स और इस तरह की प्रॉब्लम्स भी आ सकते हैं। उसमें हमने सोचा कि व्हाई नॉट टू पुट एन एक्यूस्टिक सेंसर, कि अगर कोई रैट का कोई, स्पेशली हमने रैट से शुरू किया कि उसका कोई सिग्नेचर आएगा, ऑफ कोर्स चिरपिंग और इस तरह की प्रॉब्लम आवाजें तो आएंगी, तो वो सब वो कैप्चर हो सके कि वो किस जगह पे है। ऑफ कोर्स आपको हर सेंसर का आईडी है और आप यू कैन लोकलाइज इट कि जी इस डायरेक्शन से आवाजें आ रही है या वट, और किस स्केल का प्रॉब्लम है। तो वो वन शुड एबल टू डिटेक्ट एनी सॉर्ट ऑफ acoustic signature using this device.
सही हो गया। चलें जी, फ्रॉम हेयर आई विल अलाउ शियान साहब, फैसल साहब, आई थिंक यू कैन अनम्यूट एंड you can turn on your video if you have to. फैसल साहब, can you hear me? मेरा ख्याल है फैसल साहब will be join जी।
नहीं नहीं साद, it takes a little while
अच्छा
to
अच्छा, सॉरी
join
सर।
again as a panelist.
अच्छा अच्छा,
तो, जी अस्सलाम वालेकुम डॉक्टर साहब, thank you for the
जी
presentation.
वाइट साहब।
जी, I was eager to hear what you had to say. That is why, if you saw, I joined when you had not even started. So, अच्छा डॉक्टर साहब, मेरी एक ऑब्जर्वेशन भी है, एक सवाल भी है। देखिए, मैंने कोई 23 जो है ना पब्लिक सेक्टर यूनिवर्सिटीज विजिट की 2-2.5 सालों में, between 2018 to 2020. And what I saw was that research was being duplicated in most of these universities, because most of the research which was being done was already tailored. Work had been done before, work has been done everywhere. आज भी जो मैंने ज़्यादातर सुना है, whether it's soil sensing, soil diagnostics, whether it is livestock health monitoring, whether it is artificial insemination, whether it is smart silos, all these are mature technologies. They've all been developed. They've all been commercially deployed. So what is it that we are doing in terms of research to make a breakthrough? अभी आप बता रहे थे कि जी साइलोज में, राइट, जहाँ ग्रेन स्टोरेज है, वहाँ पर रैट्स की इन्फेस्टेशन होती है, and acoustic signatures can be developed from devices which pick up sound. Again, that is technology which is very well developed. Now the problem is we can't even do it cheaper because we don't make any of those sensors. Right? हम सेंसर्स तक तो नहीं बनाते यहाँ पर। सेंसर्स या चाइना से आएंगे या बेहतर क्वालिटी जो है वो यूरोप से आएगी। मुझे थोड़ा सा इसलिए अंदाजा है क्योंकि मैं जहाँ पर था NIC लाहौर में, तो वहाँ बहुत से स्टार्टअप्स आते थे, largely from technical universities, from UET, from Faisalabad, from different even some of the private universities, जहाँ पर इलेक्ट्रॉनिक्स में रिसर्च हो रही है काफ़ी, राइट। और ज़्यादातर यूनिवर्सिटीज़ में इलेक्ट्रिकल डिपार्टमेंट जो है, इलेक्ट्रिकल इंजीनियरिंग का, वो काफ़ी एडवांस्ड है compared to mechanical and civil engineering. Most universities don't have a civil engineering department, but everybody has a double E, right? So, उस context में, water sensing or water flow sensing, right? That is very mature technology. Even at LUMS, Dr. Abu Bakr, I think 7-8 years ago, a solution was being deployed with the irrigation department, with the IRSA. IRSA के साथ भी deployment हुई because of the flow in the rivers, to make an estimation of how much water would be available. So most of these are data solutions, right? Almost all of them are data solutions, which means that the ability and capability to gather all that data and then to process all that data and then to make sense out of all that data. अब the smartphone is indeed a very powerful device, जैसे आपने कहा, बहुत powerful device है. तो इसकी जो है आगे एप्लीकेशन मैंने थोड़ी सी क्योंकि फार्मी एक स्टेज में की, आई वाज डूइंग एक्सपेरिमेंटेशन, राइट. सो मुझे उसमें पता चला कि फार्मर को सिर्फ 3 चीजों की जरूरत होती है. उसको ये पता होना चाहिए कि टेम्परेचर क्या है अगले 3-4 दिनों में. उसको ये पता चलना चाहिए कि बारिश होने वाली है या नहीं होने वाली है, क्योंकि उसने अगर हल चला दिया और उसके बाद बारिश होगी तो उसका नुकसान हो गया. उसने स्प्रे कर दिया, ऊपर से बारिश होगी, उसका नुकसान हो गया. और तीसरी चीज ह्यूमिडिटी थी. ये 3 चीजें थी. मैं बात कर रहा हूँ जी 2010 की, 2009 की, 2009 या 2009-2010 की बात कर रहा हूँ. तो मेरे पास मेरे साथ जो मुझे हेल्प कर रहे थे वो एग्री यूनिवर्सिटी से थे और वो एक एसएमएस भेजते थे. ये 3 चीजें उसमें होती थी, ठीक है ना. तो वहां से वहां तक, बिकॉज अ लॉट ऑफ दीज टेक्नोलॉजीज दैट वी टॉक अबाउट, दीज आर नॉट अफोर्डेबल बाय आवर फार्मर्स. वो 3 से 5 एकड़ का फार्मर है, वो बेचारा कहाँ से सॉइल सेंसस लगाएगा और कहाँ से वो करेगा. उसको SaaS सॉल्यूशंस चाहिए होंगे, ठीक है ना. उसको सिर्फ इनसाइट चाहिए होगी, उसको कोई और चीज नहीं चाहिए, उसको सिर्फ इनसाइट चाहिए. आई हैव सीन न्यूमरस एप्लीकेशंस और सॉल्यूशंस बेस्ड ऑन ड्रोन्स. जर्मनी में 10 साल पहले वो ड्रोन के थ्रू जो है वो स्पेक्ट्रोग्राफिक एनालिसिस करके यील्ड एस्टिमेशन कर रहे होते थे, ठीक है ना. इसमें कैलिफोर्निया में ऑरेंजेस की प्रोडक्शन, बिकॉज ऑरेंजेस का फ्यूचर ट्रेड होता है, ऑरेंजेस की एक पूरी कमोडिटी मार्केट है, राइट. सो द यील्ड एस्टिमेशन बिकम्स अ वेरी पावरफुल टूल in the hands of people who are running the commodity market, right. और वो ऑरेंजेस की एस्टिमेशन तो हमें 20 साल पहले से हो रही थी कि हार्वेस्ट एंड यील्ड की आप एस्टिमेशन कर सकें. In a university, you know, in our university environments, we need to now tailor research to technology that is quickly deployable, that can be tested fast. If it works, you retain. If it doesn't, you abandon and you move on, right? Because मैंने देखा है पिछले 5 सालों में, in fact, just before COVID last year, March में, we had invited 120 researchers from multiple universities who were going to come to LUMS. We were going to host them. And the purpose was to look at commercialization of research. कि research की direction क्या होनी चाहिए, research किस direction में जानी चाहिए जिसकी commercialization भी तेज हो सके और real benefit हो सके. तो मेरा सवाल ये है कि ये जो हम बातें कर रहे हैं, अब देखिए बनी ब्रेड वालों को 40 करोड़ रुपए मिला करंदाज से for smart storage, right? It will have all the things that we are talking about, you know, all kinds of sensors. And once you lock it, the only time you'll open it once is when you want to take everything out of it, right? तो वो उस level तक उसकी जो है ना वो उसमें intelligence है, right? So ये सारी चीजें हैं. So how do we bring research to the market, research to the field, research to the effective use of farmers in, let's say, in the next 3 to 5 years? Nothing longer than 3 years, if we are talking today.
So, thank you very much for comprehensive, analysis. अच्छा, इसमें जब हमने एक्चुअली जब मैंने शुरू किया 2-3 साल पहले, इनफैक्ट 1.5-2 साल पहले आप, तो एग्रीकल्चर डिपार्टमेंट जो पंजाब है उन्होंने कहा कि जी दे आर गेटिंग, उनके पास न्यूट्रन मीटर है, ये उस तरह के मीटर्स हैं जो कि सिंपली दे आर पोर्टेबल हैंड, और उन्होंने कहा जी ये हम जो है ना बाहर से मंगाते हैं, मतलब कॉन्ट्रैक्टर के थ्रू एंड व्हाटएवर, और ये हमें कोई 30-40 हज़ार का पड़ता है ये वाला मीटर जो है ना. मतलब आई एम नॉट टॉकिंग अबाउट दैट चाइनीज मीटर जो 2 prong, वो तो लाइक इट कॉस्ट हार्डली 1000 और 2000 रुपीज. लेकिन वो हॉबी है, लाइक गार्डनिंग और इस तरह के पर्पसेस के लिए तो परहैप्स ठीक है, लेकिन एक रगेडाइज कमर्शियल चीज नहीं है. तो हमने कहा अच्छा ठीक है, हम लेट्स ट्राई कंडक्टिविटी, और यही प्रिंसिपल है, तो हम क्यों ना सॉइल के ऊपर जरा उसको देखते हैं. तो आई स्टार्टेड विद दैट मोटिवेशन कि जी हम इंडिजिनस कोई चीज, अनफॉर्चुनेटली ये है कि अभी फॉर एग्जांपल आप लम्स की भी बिल्कुल बात कर रहे हैं, बट देयर इज नो वन इन एनी यूनिवर्सिटी के इस तरह का पोर्टेबल मीटर जो है ना. और फिर हमने इसको ऑफ कोर्स वी वेंट नेक्स्ट माइल कि हम इसको स्मार्ट बनाएं कि एटलीस्ट डेटा एक्वायर करें, और नेक्स्ट आर नाउ विजन इज कि उस डेटा को हम एक्वायर करें और फिर उसके ऊपर एनालिटिक्स लगाएं दैट इज द रियल वैल्यू जो कि हम इससे लेके आ सकते हैं. कमिंग बैक टू द पॉइंट के अब इस तरह का अभी तक अनफॉर्चुनेटली नो यूनिवर्सिटी इन पाकिस्तान, नो ऑर्गेनाइजेशन जो कि इस तरह के फॉर्म फैक्टर में और वी आर आल्सो फोकसिंग ऑन लो कास्ट थिंग. ठीक है, तो थिंक आपके यही चीज हम 10,000 से नीचे अगर अगर फॉर एग्जांपल गवर्नमेंट को देते हैं, वो सब्सिडाइज करके फार्मर को 2,000 का भी दे देती है और ये कम्युनिटी इसको पूरी कम्युनिटी इसको यूज कर सकती है. और ये IoT पावर्ड भी है और ऑल द डेटा इज जैसे coming back to the for example the organization, department or the university, और वो डेटा के ऊपर फिर फाइनल थिंग इज वंस वी हैव द डेटा, फिर उसके ऊपर हम एनालिटिक्स कर सकते हैं, मॉडल्स बिल्ड कर सकते हैं, जोनिंग कर सकते हैं एंड थिंग्स लाइक दैट. तो डेटा इज द प्राइमरी थिंग. और इसलिए मैंने जितनी भी चीजों की बात की है उसमें IoT मैंने पर्पसफुली उसके अंदर डाला है कि वो डेटा वंस वी गेट द डेटा दैट इज द रियल वैल्यू जो कि हम लोकलाइज्ड इन्वायरमेंट के अंदर कोई भी डेटा में बाहर से नहीं देगा, ना चाइनीज देंगे ना US का, मतलब वी कैन ब्रिंग इन द सेंसर्स. ठीक है, और इसमें भी ये ऑफ कोर्स वी नीड टू गो टू द चाइनीज फॉर द ICs एंड दोस काइंड ऑफ थिंग, बट सिस्टम हैज इट्स ओन वैल्यू. तो मतलब ठीक है, आई टोटली अंडरस्टैंड कि ये कोई इस तरह की टेक्नोलॉजीज अभी तक नहीं हमने डेवलप की जो कि बहुत कटिंग एज हो. बट अनफॉर्चुनेटली पाकिस्तान के अंदर तो इतना भी नहीं हो रहा कि फॉर एग्जाम्पल ये एक्टिविटी मॉनिटरिंग है, ये इस तरह की जो सिस्टम्स है ना, मतलब इवन साइलोस के ऊपर सारी टेक्नोलॉजीज बाहर से हम इंपोर्ट कर रहे हैं और डिप्लॉय कर रहे हैं. द थिंग इज के वन शुड हैव द इंडिजिनस सिस्टम्स, उसका OEM जो है ना ऑपरेशन और मेंटेनेंस उसकी, मतलब वंस यू हैव द टेक्नोलॉजी इन हैंड इन हाउस, तो आप बेसिकली ये काम आसानी से कर सकते हैं. द रियल विजन आई कैन सी इज द डेटा, राइट. ये इसलिए मैंने गैजेट्स जो है वो बनाए हैं ताकि हम इनको डिप्लॉय करें. फॉर एग्जांपल जो साइलो वाला है, हमने एग्रो के साथ जाके इस सीजन में, पिछले सीजन में हम जाके डिप्लॉय किया, वी गॉट सर्टेन एनालिटिक्स, हमने उसको चलाया, कुछ चीजें हमने उसमें ऑफ कोर्स विल इंप्रूव इट, बट द थिंग इज कि वी हैव टू स्टार्ट फ्रॉम समवेयर. और पाकिस्तान में आई नो के लम्स में दे आर आल्सो वर्किंग ऑन अ मीटर, sorry meter, but वो generally is not portable, you have to fix it somewhere. तो मतलब there are people doing work in bits and pieces, but इन टेक्नोलॉजीज पे इंडिजिनाइजेशन के लिए जो है ना, वो माय एफर्ट वाज के एक तो हम लोकली यहाँ पे ही सिस्टम्स बनाए, दूसरा ये है कि दे शुड बी स्मार्ट सो दैट वी कैन गेट द डेटा, और डेटा की बेस के ऊपर फिर आगे हम मॉडल बिल्ड करें एंड सो ऑन.
Gee, Dr. Sahab, I understand. Absolutely. Data is the key. Data is the critical element, right? If we are an agri nation, and which we are, इस दफा जो हमारी GDP ग्रोथ हुई है वो सारा के सारा बहुत ज्यादा उसका इन्हिसार जो है वो एग्रीकल्चर पे था. That a better yield came in. लेकिन so we have to improve that, and we have to use precision farming. We have to use techniques which empower the farm. देखिए, farmer is more or less interested in the inside. The farmer is not interested in anything more. Right, so the insight has to be created. So the business model, because they come from the aspect of what can go to market, right? Something research that can make it to market, right? Research making it to market is the critical factor. Otherwise, वो research रह जाती है. ठीक है ना? It's good research, but वो marketable नहीं होती. So when we talk about indigenization, we have to talk about the ability to be able to produce these devices. वो बहुत ही क्रिटिकल एलिमेंट है कि जी वो कहाँ प्रोड्यूस होगी, कौन प्रोड्यूस करेगा. दे आर वेरी स्मार्ट किड्स. I mean, I know so many of them because I have been in that landscape. They're very good mechatronic engineers. There are very good electrical engineers. Now, increasingly, there are kids who understand edge computing, who understand, bringing data to the cloud and being able to process that data. मैंने टेलको में काम किया हुआ है 2002 और 2001 2002 में इन द यूके. सो टेलको के पास इतना ज्यादा डेटा आता है कि अगर आप उसको प्रोसेस ना कर सकें वो फॉग है, नजर ही कुछ नहीं आता आपको. और पाकिस्तान की टेलकोस जो है अनफॉर्चुनेटली यही हाल है उनका. उनके पास एक मतलब जैसे टेलीनॉर है, उसके पास डेली जो है को 25 बिलियन डेटा पॉइंट्स आते हैं, 25 बिलियन डेली. And they don't have the capability of processing that. That's why they don't know the customer. उनको अगर आप पूछें कि अब बताइए आपके 30 मिलियन कस्टमर्स में से कितने कस्टमर्स हैं जो फार्मर्स हैं, कितने कस्टमर्स हैं जो बखर में हैं, कितने हैं जो साहिवाल में हैं, कितने हैं जो रहीमयार खान में है, ठीक है ना. दे विल नॉट बी एबल टू टेल because they don't have the capability of processing that data. उनको अगर जब तक आप हाथ उठा के ना कहे ना कि जी मैं फार्मर हूं और मैं आपका बाखबर किसान ज्वाइन करना चाहता हूं, उनको नहीं पता कि आप कौन हैं और आप कहाँ हैं, ठीक है ना. They don't make any sense of the data. I've been there, I've met them, I've spoken to them.
जी फैसल साहब, मेरा ख्याल है फैसल साहब इसमें इनसाइट तो काफी है. मेरा ख्याल है शहजाद साहब के पास भी जवाब होंगे और फिर एक लॉन्गर कॉन्वर्सेशन भी बन सकती है. मेरा ख्याल है इसका एक फॉलो अप सेशन भी रख लेते हैं एज अ फायर साइड चैट बिटवीन अ रिस्ट्रिक्टेड ऑडियंस. मैं जस्ट इन द इंटरेस्ट ऑफ टाइम एक सवाल है अगर मैं शहजाद साहब पूछ सकूं. द प्रॉब्लम विद स्पेक्ट्रल कैमरा इज दैट दे आर सुपर एक्सपेंसिव इवन फॉर अ लार्ज स्केल फार्मर. The idea is to make a cost-effective spectral camera. मेरा ख्याल है you agree with the observation. या आप लोग कैमरा बनाने की तरफ फोकस कर रहे हैं या नहीं?
फिलहाल तो मैं तो उसको वीएन नहीं कर रहा, लाइक आई शुड वर्क ऑन द कैमरा, बट because that involves some IC technologies and electronics, really fundamental electronics and so on. But I know someone in NUST जो कि maybe they are working on these kind of technologies, so perhaps, but I myself is not into that kind of thing.
Okay. चलें जी. Anyway, मेरा ख्याल है just in the interest of time, I think we went a little bit over. हमारी कोशिश होती है 30 minutes प्रेजेंटेशन के बाद 15 minutes QA के कर लें. फिर लेकिन फैसल साहब ने माशाल्लाह हमें बड़ा एक अच्छा इनपुट दिया और बड़ा इंसाइट है. इंडस्ट्री में काफ़ी इनका नाम है और काफ़ी इनकी डेप्थ नॉलेज की. मेरा ख्याल है we will set up a follow up session discussion just to talk about very specific things. लेकिन thank you all. Thank you फैसल साहब, especially you for joining the call today and for this discussion. And hopefully we will put up this recorded session on YouTube for other people to reference. So thank you everybody. Assalamu alaikum.
Thank you,
just the
last
thing.
Ji.
Last comment. Actually, the idea of developing these technologies is to to send them in the field and get the data, and it's where I am looking for the collaborations. So now you can use these gadgets. We can make a scenario or a case, and then we can together deploy this. So maybe someone can go to the field or is already in the field. I'm willing to join hand to share my gadgets, and once we have the data and then we have the capability to process it. So it's just where I'm looking to collaborate with others, so they can help us making the scenarios and getting the data and then doing the research on that.
Perfect. Faisal Saab, any closing comments from your side?
Gee, I think Dr. Saab has just hit the nail on the head. So we need to get these technologies into the field, test, see what works, get the data, see how our soil behaves. Does it behave differently from any other soil? Because we are using certain technology. I think so. But the accuracy of the probe, right? That can only be improved with the data that we get from the results of the probe. So yes, collaboration is very important. I'm hoping that in this group, there will be people who will say, we'd like to work with you, Dr. Saab, and get your technology in the field and test it out.
Absolutely. Absolutely. Anyway, thank you so much. Inshallah, we will set up something as a follow-up. Thank you everybody for joining. Assalamu alaikum.
Thank you. Thank you.
Allah Hafiz.